Since our course is concerned mainly with applications of different concepts that we learn, different mathematical concepts, it's going to be important to be able to interpret the meaning of intercepts in application problems. So, y-intercepts in application problems almost always can be thought of as initial or starting values in a problem. All right. So that's pretty standard for application problems. Y-intercept is the initial value or the starting value of a specific problem. The x-intercept now depends. Sometimes really the x-intercept doesn't even have a practical meaning, but when it does, a lot of times it can be thought of as an ending point. So y-intercept is generally always going to be the initial or the starting value, and the x-intercept sometimes has no meaning, but when it does, probably it's like an ending point. Now, what does this mean? Well, it depends on the specific problem that you're dealing with. So we'll look at a couple here. So the equation y equals 24 plus 0.049x can give the cost y of driving x miles with a moving truck that has been rented. So y is the total cost and x is the number of miles that you're driving with this moving truck. So in the case of this one, all right, well, let's think about the y-intercept, right? The y-intercept is going to be the value of y when x equals 0. So when x equals 0, we're going to get y equals 24 plus 0.49 times 0. So that's just going to be 0. So it's just going to be y equals 24. So the y-intercept is the 0, comma 24. So in this case, what this means is x is 0, so that means 0 miles. Y is 24. That means the cost is $24, right? I mean, we're assuming it's in dollars. They don't tell you that up here, but they should. So 0 miles, $24. So what that means is before you've even driven anywhere, you're getting charged $24. So sometimes you can refer to that as the initial fee, right? So the initial fee or the initial cost of the truck is $24, right? Because you haven't driven anywhere yet. You're just basically saying, all right, I'm going to rent. So then they're going to say, all right, you're paying $24, which is pretty standard for those moving trucks. You see some of those U-Hauls, oh, 19.99 per day for local rentals. Well, that's what it is, yeah, but then you have to pay a per mileage rate, okay? So the initial cost of the truck is $24. So that's what the y-intercept means. Now the x-intercept in this case, let's see. So if we do the x-intercept, you're letting y equal 0. So we would have 0 equals 24 plus 0.49x. And we're going to have to solve this for x. So we're going to have to subtract 24 and then divide by 0.49. So there's no space here, so I'm just going to do it quick. So if we subtract 24, we have negative 24, and then we divide by 0.49. So 24 divided by 0.49, it's going to be a decimal. Let me just grab my calculator here. If I do 24 divided by 0.49, oops, this calculator is dead, it sounds like. Huh, that's not good. So 24 divided by 0.49, it's negative though, so it's like 48. Let's say it's 49, so it's like negative 49. So, and remember what x measures is miles. So like in this case, is it possible to drive negative 49 miles? No, not possible to drive negative 49 miles. So in this case, the x-intercept, no practical meaning. because you can't have negative miles. Okay, so in that case, the y-intercept, yes, it was the initial cost, $24, but the x-intercept had no meaning. So let's see this one. So with this one, give me a little bit more space here maybe. The function f of x equals 36 minus 3x gives the dollars remaining on a gift card that has been used x times. So this was pretty typical of our Unit 1 problems, right? We had these gift card problems. So y is going to be the, or f of x actually, is the dollars remaining, and x is the number of times the gift card has been used. So like in this case, again, y-intercept, x equals 0. So we're really finding f of 0, like if remember this from the function notation, but remember f of x is really y, so we're really saying y equals, but it's f of 0 equals 36 minus 3 times 0. So this is just going to be 36 minus 0, which is just going to be 36. So again, yes, this is going to work because x being 0 means it hasn't been used yet, right? So the initial or the starting value of the card, right? Right? Because this is a y value, so it's the amount remaining. So the starting value, well, let me write the point first. Remember we said intercepts are always points, so it's 0, 36. So the starting value of the card is $36, right? Or the initial value. So the initial value of the card is $36. So that was what our y-intercept meant. And then in this case, our x-intercept is also going to have a meaning, actually. So let's see. So the x-intercept, you're going to let y equal 0. But again, remember, f of x is really y. So what we're doing here is we're replacing the whole left side with 0. So we have 0 equals 36 minus 3x. So if we add 3x to both sides, we'll have 3x equals 36. And then if we'll divide both sides by 3, we'll get x equals 12. So then this ordered pair is 12, 0. So in this case, 0 is the amount remaining, and 12 is the amount of times it's been used. So what we're saying here is, yes, it is like an ending point here, because what we're saying is after the card has been used 12 times, it has $0 remaining, or it has no value, right? $0 remaining, or it just has no value. So that's the ending point. So yes, in this case, the y-intercept was the starting point, and the x-intercept was kind of the ending point, right? Where it was used up. It was all out of value.